little bit different of a JK today. We're in a two-door that has a lot of character. Of course, we're on 1 tons. We've got a gated shifter, vertical AC controls. Actually, there is no AC in this Jeep, but the heater works really good. We got full hydraulic steering. You can see our dash is a Christmas tree. When you go to hydraulic steering, you pretty much lose a lot of your ESP function. The steering angle sensor in this vehicle is not functional. So basically our ESP is gone. This JK has an LS3 in it, and I believe it was just rolled over at Moab. If not rolled over, it went on its side. If we continue our discussion on the evolution of the internal combustion engine in automobiles, I think we left off with the positive crankcase ventilation system, and the positive crankcase ventilation system really cleaned things up. In fact, I think that was the biggest gain in emissions over the years, because scavenging the byproduct of combustion from the crankcase and reburning it meant that we weren't just pushing that into the atmosphere. By the early 60s, we got pretty serious about cleaning up emissions. The first thing we had to target was gases that we kind of knew about, and that would have been carbon monoxide and hydrocarbons. I think we've discussed that hydrocarbons are basically raw fuel. We've all heard of carbon monoxide and carbon dioxide. Carbon monoxide is basically a byproduct. It's a partially burned fuel atom. That's kind of what a carbon monoxide is. So if you think of a marshmallow that's white and then you put it into a campfire and the outer edges get burnt but the inside is still white, that's kind of what a carbon monoxide atom is. It's still burnable or volatile. If that gets into the atmosphere, that's a bad gas. If hydrocarbon gets into the atmosphere, that's a bad gas. So these were the gases that we started to target. How do we reduce the COs and the HCs? Well, engine technology was really improving. In the 50s, the overhead valve, Fords and Chevys, the small blocks, the combustion chambers got better, the compression ratios got raised. The engine design just became more efficient. Obviously, back in the 50s and 60s, we're still using carburetors. Carburetors got pretty advanced. Even in the 1980s, they added feedback carburetors, like little solenoids that can control mixture based off of an oxygen sensor feedback reading. But in the 50s and 60s, they weren't that sophisticated. So they did their best to get the carburetor as efficient as they could. But remember, back then, fossil fuels were cheap. Emissions weren't on the mind of people like it is today. So they didn't try to make the efforts that we have today to clean up the environment. And for the most part, carburetors ran pretty decent if you ran them in a steady state going down the highway. But the transitional periods, like accelerating, there's idle transfer ports, wide open throttle, deceleration. Most of you guys remember the old Holleys and Rochesters with the secondaries. When the secondaries would open, it would bring in a new set of jets. The mixture would get rich. And while that worked 50 years ago, it's obviously not what we're doing today. Today we're trying to minimize emissions as much as we can in every way that we can. Stop-start, for example. The new JL has stop-start, so when you come to a stop, turning the engine off for that 30 seconds or whatever can actually reduce the emissions output a slight amount, as well as improve gas mileage. So we're reaching for every incremental improvement today, but back then there were huge improvements that could be had. Looking at hydrocarbons and carbon monoxide, these are two bad gases. Let's talk about the gases a second, just the basics. So carbon monoxide we talked about is partially burned fuel, bad gas. Hydrocarbon, basically raw fuel, bad gas. O2, oxygen, good gas. Nitrogen, NO, good gas. H2O, water, good. NOx, bad gas, and we'll talk about that later. So really, the goal of any engine performance system is to take gases in and put them out, and put out the least harmful gases possible. So when these elements go into your engine, let's say the primary air into the intake, that's nitrogen and oxygen. About 79% nitrogen and about 21% oxygen. What comes out the tailpipe is what matters, and what's in between is the emission systems. Catalytic converters, secondary air systems, PCV valves, EGR valves, you name it. There's all sorts of emission systems, and most of them are not well understood. So obviously the first thing we could do to reduce the hydrocarbons and CO output was to lean these motors out, and that's exactly what they did. They started leaning the mixtures out, getting closer and closer to what they thought was the perfect mixture. As we all know today, stoichiometric is about 14.7 to 1. Now there are advantages to run above and below stoichiometric. So if you go above stoichiometric, let's say with gasoline you go to 15, 16, 17, 18 to 1, you're leaning the motor out, therefore you get better economy. And in some ways your CO and HC emissions drop. If you lean the motor out too much, it's going to start to misfire, and that's going to increase your hydrocarbon output. What's hydrocarbons? It's basically raw gasoline. So if the engine's misfiring, it's not burning that gasoline, it's going right into the exhaust, and your hydrocarbon output goes up. Hydrocarbons are measured in parts per million, ppm. If the mixture is too rich, there's too much fuel going into the engine based on its need and the available oxygen content, then you're going to be putting out CO, or carbon monoxide. Carbon monoxide is a partially burned hydrocarbon atom. So if the mixture is too rich, the engine just can't physically burn all that fuel, and it puts it out into the exhaust. So now we have hydrocarbons and carbon monoxide, both bad gases, but both gases that are still volatile, meaning they can still burn. So we have hope to recover and or eliminate these gases through the engine performance system. One gas we didn't really know about back then was NOx, or NOx. That's when nitrogen atoms and oxygen atoms melt together. And we'll talk about NOx later. X represents the number of oxygen atoms that are on the nitrogen atom. And NOx is a bad gas. It can be more difficult to test for NOx because an engine must be under a load and the combustion chambers must be hot for NOx formation. So we'll talk about that later. So what ended up happening was we started to lean these carburetors out. We also started to come up with automatic mechanical systems like Advance. We've all seen vacuum advance systems and centrifugal weights to control spark timing in the motors from the 50s, 60s, 70s. And we basically had to do this all mechanically because we did not have the electronics that we have today. So by leaning these carburetors out, we did reduce the CO and the HC emissions. One of the considerations was if you had a heavy-duty truck and you were going up a steep grade and you were towing a trailer, if you ran it too lean, you could reduce the life of the engine or, worse, blow the motor up. So we had power valves and other things that would richen the motor up. We had to have these different systems to enrich the motor under a heavy load. But for the most part, they leaned these carburetors out till the hydrocarbon and the CO emissions was very low. In fact, in some cases, too low. While manufacturers lean the carburetors out more and more, in areas like Los Angeles, we were still seeing smog. We knew our HC and CO output was down significantly, but we saw this brown layer, and it wasn't well understood why. And we're going to talk about that in another video. We're going to concentrate on the HC and the CO now. So getting back to the engines of the 60s and 70s, all sorts of things came up to help reduce CO and HC. First thing was to burn as much HC as we could in the combustion chamber so not much of it got out. Engine efficiency back then wasn't too bad, so most of the gasoline was burned.